So one of the cool things that you did in the previous video when we looked at sine, cosine, tangent, and the reciprocal functions is you pondered about what would the positivity and negativity be on a coordinate plane. So here I have a coordinate plane, it's blank, and we're going to fill in the quadrant numbers and names. So this is going to be quadrant 1, and we're going to use Roman numerals to show that. This is going to be quadrant 2, this is going to be quadrant 3, and this is going to be quadrant 4, using Roman numerals like we always do. We're going to go counterclockwise from 1 through 4, and we're going to talk about positivity and negativity on x and y. So x and y are both positive in the first quadrant, since we have our x there on the x-axis and the y there on the y-axis. We're also going to assume this is the unit circle, so therefore this is going to be a distance of 1, and that's going to also be a distance of 1. So going to this part, the second quadrant, where x's are negative and y's are positive. And in the third quadrant, x's are negative and y's are negative. And in the fourth quadrant, x's are positive and y's are negative. Now this is really important to have because what we're about to do is we're about to figure out and make a table of our different quadrant positivity and negativity values for the 6 trigonometric functions. So sine is going to be y, and I made my students say sine aloud because sine is like the sine y. And the reason why it's just y is because according to SOHCAHTOA, sine is opposite over hypotenuse, and since we have a unit circle, opposite, which is the y value, over hypotenuse is 1, so y divided by 1 is y. And therefore cosine is just x, because that would be the adjacent side, x, over the hypotenuse, 1, and x divided by 1 is 1. Now, the secant is the reciprocal of cosine. So this is going to be 1 over x. And the cosecant is the reciprocal of sine. So this is going to be 1 over y. If you want to see these fully derived, you can go back to session 1 videos and watch those. The tangent is y over x, and the cotangent is x over y. I like to think of tangent, if you're struggling like, oh gosh, what is tangent, x over y, or is that cotangent? I like to think tangent is slope. I mean, that's a bit of a stretch, but I think some better math teachers can make a pretty cool connection out of tangent and slope. But that's the way you could think of tangent. It's y over x. So in terms of quadrant 1, the sine and the cosine and literally everything else is going to be positive in quadrant 1. But let's just go across this direction because it's going to be easier to fill this out by the row than it is by the column. So thinking about sine, now sine is a y value. When are y's positive? Well, they're positive in the first and second quadrant. And therefore, the y's would be negative in the third and the fourth quadrant. Now you'll note that sine and cosecant are reciprocals. So if you flip 1 over y, positive numbers still stay positive even if their reciprocals are taken. And their negatives stay negative even if their reciprocals are taken. So you can see that the sine and the cosecant are going to have the same positivity and negativity. Now, cosine is an x value, so it's negative in the second quadrant, and it's also negative in the third quadrant. Take a look at your x values, and then positive in the fourth quadrant. Now, taking the reciprocal of x isn't going to change the positivity and negativity, so you can now see that the cosine and the secant are going to be also the same. How about tangent and cotangent? Well, y divided by x, so positive divided by positive is positive. And positive divided by negative is negative. This is the only, whoops, sorry, didn't see my positive didn't get made there. So again, positive divided by positive is positive. Positive divided by negative is negative. Now in the third quadrant, negative divided by negative is positive. And negative divided by positive is negative. So you can see that tangent is negative in the second and fourth quadrant. And we had to kind of derive that because we had to go y divided by x. So we looked at their positivities and negativities and created this chart. The cotangent is going to be exactly the same because the reciprocal of x over y and y over x are not going to change their output values. So here's my tangent and cotangent matching as well. Now what's great about this is we can keep this beautiful symmetry and synergy as we do inspection around what quadrants are the point located. And you'll have a few of these on your homework and the test probably. So let's go take a look here. What quadrant is point T located if cosecant is negative? Okay, cosecant's negative in the third quadrant and the fourth quadrant. I like to just do a little scrap work here just so you can see what quadrants I'm thinking of, and because it's kind of hard to do it in your head if you're trying to, because cosecant is negative, so it's either the third or fourth, and tangent is negative, so that's either second or fourth. And since cosecant is the fourth and tangent is the fourth, this is the one they have in common. So this is your answer, fourth quadrant. Now what about the cotangent? When is cotangent positive? Cotangent's positive, looks like first and third quadrant. So first and third. And secant is negative. Secant is negative in second and third. All right, well, so if it's like kind of like people ordering pizzas, right? If this person wants a first quadrant pizza and a third quadrant pizza, and this person wants a second quadrant pizza and a third quadrant pizza, they'll both be happy if you give them the third quadrant. And then you can go and look in the third quadrant and see that these relationships hold perfectly. We are going to take a look at a given SOHCAHTOA relationship to a point in a quadrant that's given, and then we need to find the 5 remaining trigonometric identities. So, I'm going to have to draw a picture here, because doing this in your head is darn near impossible, and also just doing the math out without seeing the picture is also, I'm going to start to question how you're doing it, right? So, it looks like T is in the second quadrant, so we're going to make a line in the second quadrant, put a dot T there, and then we're going to make a reference angle from there, from my angle theta to my point T, and this is going to be finding the 5 trigonometric functions. So my sine is the relationship of opposite over hypotenuse, that's according to SOHCAHTOA, and so therefore this would be 3 and 5. Now, one of the ways that I know I did this right is you'll notice that the y value is positive in the second quadrant, and the hypotenuse is always positive. So now what we get to do is we get to kind of like finish the problem up and see like, okay, we need to find this missing piece x. We need that missing piece x right there because we need to show all of the other 5 trigonometric functions, and we're going to need to know this for, first of all, we're just going to need to know it for cosine, because cosine is an adjacent relationship. So we're going to bust out my Pythagorean theorem, x squared plus y squared is equal to h squared. X is going to be unknown, but we do know my y, which is 3, and we do know my hypotenuse, which is 5. So x squared plus 9 is equal to 25. Then we subtract 9 from both sides using inverse operations. X squared is equal to 16. Okay, so I'm going to take the square root of x squared and the square root of 16. So this gives me x is equal to plus or minus the square root of 16, which is 4. Okay, a couple of you in watching these might have just recognized the Pythagorean triple right away. It's great if you can save yourself some time, but I just wanted to show you how it's derived. Now here, I get to choose plus or minus. Now since my x value is in the second quadrant, I'm going to have to choose the minus of this. So this is going to be a negative 4, which is crazy important because as we do the remaining 5 trigonometric functions, so let's start off with cosine of our theta. Cosine t is equal to the adjacent over hypotenuse. Then we're going to go with its reciprocal, the secant of t, which is going to be this reciprocal, so negative 5/4. You're probably wondering, where does the negative go? Does it go on top or bottom or the middle? And the answer is, yeah, it should go one of those 3 places. Generally, the top or the middle is probably the best math grammar there. Okay, what about cosecant, which is the reciprocal of secant? Well, cosecant, the reciprocal of secant, is going to be 5/3. And then we have tangent of our angle theta. The tangent of angle theta is going to be opposite over adjacent, which in this case the 4 is negative, so we can put that negative again, top, bottom, or middle, but middle or top is generally standard. And then cotangent of theta is going to be the reciprocal of this, which is adjacent over hypotenuse. Super. So that's problem number 11. And that was pretty nice and straightforward because we had a nice Pythagorean triple. Also, we had to be a little careful because we were in the second quadrant. Can't be too careful here. So now we're going to get to our next example. And it's a little bit tougher to understand because it doesn't tell you the exact quadrant right away. It doesn't say in words what quadrant it is in, but it gives you a hint. This is where you would determine your quadrant. So you'll notice that the t, or our theta, is between pi, which is 180 degrees, and 3 pi over 2. Thanks to your chart, 3 pi over 2 is 270 degrees. Now, what quadrant are you in if you're between, and not including, 180 degrees and 270? Yeah, you're right. You would be in the third quadrant. This is going to be a little bit of a tricky triangle because in the third quadrant, for our angle theta, we don't, again, I'm not drawing it to scale, but it looks like the tangent, according to SOHCAHTOA, to angle theta is going to be the opposite over adjacent. So opposite over adjacent. Now, what I just wrote down is probably not what you wrote down because I wrote down opposite over adjacent, and you're noticing they're both negative. And you're just going like, huh, why? And well, it's because we're in the third quadrant, and x values and y values are negative in the third quadrant. Yeah, but the tangent's positive. I understand the tangent's positive because opposite over adjacent would be two negatives to make a positive. Man, I'm telling you, this third quadrant's going to trip you up. So be aware when the third quadrant, your x and y both have to be positive, and for all of these examples, our hypotenuse is going to be positive as well. So what we have is whoops, just scroll down there a little bit. So we have x squared plus y squared is equal to hypotenuse squared. And please be sure that you put your values correctly. Put your values correctly for x and y. Let me do that. That's going to be my negative 12. But you'll notice I'm using parentheses. When I substitute, I always use parentheses. And that gives me the correct answer when I square these. Negative 12 squared is positive 144. Negative 5 squared is positive 25, equal to hypotenuse squared. Or 169 equals hypotenuse squared. Take the square root, and for hypotenuses, I do not have to be concerned with plus minus because it's always going to be positive. So the square root of both of these is going to be 13. So I can put this in my picture now. That's my 13. So if that's my tangent, I can now figure out the rest. I started with cosine. That's just weird. I think all of us reflexively are going to start with sine. So the sine of theta is going to be opposite over hypotenuse. Cosine of theta is going to be adjacent over hypotenuse. Tangent is given, so cotangent is going to be the reciprocal of 5/12, which is 12/5. The reciprocal of sine is cosecant theta, and that's going to be negative 13/5. And the reciprocal of cosine is secant, and secant theta is going to be negative 13/12. All right, that was tricky, right? And it was tricky because of that silly third quadrant, and especially if since I gave you the tangent value. That's pretty mean, wasn't it? Pretty easy to miss the negative 5 and the negative 12. So for our last problem on this page, I want you to first section off the odd-even functions because we are going to talk about the odd-even functions in another video, but we're going to finish off this problem here. The cosine of t and the sine is less than 0. Now this is a really interesting puzzle because it looks like I didn't give you enough information. because it says here the sine of t, or theta, is less than 0. So sine, again, is our y value, and our y is less than 0. So when is y negative? I believe that's the third quadrant and the fourth quadrant. So you might think to yourself, well, shoot, I don't know, I got a 50-50 shot at this. Well, don't forget about this problem here. Cosine is an x value. And you can see by the 3/4 that cosine is positive. You see how 3/4 is a positive value? So that's where you get your last piece to solve this puzzle of which quadrant am I in, because the cosine is positive. The cosine is 3/4, which means the cosine is in quadrants 1 or 4. And therefore, this is in quadrant 4, because the positive cosine is in the fourth quadrant, and the negative sine is in the fourth quadrant as well, so we make our triangle in the fourth quadrant. Put a little right triangle there. This is our angle theta. And now we're going to use our relationship of cosine, which is adjacent over hypotenuse. And I know I did this problem right, because the 3 is positive, just as it would be in the first quadrant and the fourth quadrant, and the hypotenuse is always positive, so we just need to find this negative y value. So we got x squared plus y squared is equal to h squared. We're going to kind of plug in my x. My x is going to be 3. My y is going to be, I don't know. And my hypotenuse is going to be 4. So 9 plus y squared is equal to 16. Subtract 9 from both sides using inverse operations, and y is equal to, this is interesting, 7. So if I take the square root of both sides, y is going to be equal to plus or minus the square root of 7. Which one is it? Well, since we're talking about the fourth quadrant, we're going to look at this negative value here. So y is equal to negative square root of 7. Well, so that means we're going to use these three values to figure out the rest of this. So the sine is going to be equal to the, I should really put sine of t. I'm sorry about that. Let's make that a little bit better and move a little bit to the left, anticipating the work I have to do. So the sine of t is equal to negative square root of 7 over 4, because that is, according to SOHCAHTOA, opposite over hypotenuse. We know the cosine already, so that gives us, let's go down to tangent here. The tangent is going to be our opposite over adjacent, which is negative square root of 7 over 4. Okay, let's do some reciprocal functions here. The reciprocal of sine of t is going to be the cosecant of t, and that's going to give me 4 over negative square root of 7. Now we can't leave the square root in the denominator. It's not good math grammar. So I'm going to multiply by 1 here, which is square root of 7 over square root of 7. And this gives me 4 square root of 7 over the square root of 49, which is just 7. And don't forget to slap your negative in there, because you'll need that for your correct cosecant answer. Now, the reciprocal of cosine is secant, and that's really great, because the reciprocal of 3/4 is 4/3. Ah, that's nice. And the reciprocal of tangent is cotangent. And, I forgot my t there. Gah. All right, and that's going to be 4 over well, actually, let's see, cotangent, opposite over adjacent. Oh, that's a 3. Silly me. I didn't want to leave that up there. All right, gosh, making mistakes all day. And so this is going to be in my numerator. This is also me not wanting to remake my whole video from that little mistake there, since I caught it. 3 over negative square root of 7. And again, I don't like the square root of 7 in the denominator, so I'm multiplying by 1, the square root of 7 over square root of 7. And so what I have here is 3 square root of 7 over square root of 49, which is 7. And you slap a negative in front of that, and you get your cotangent. So in the next video, we are going to talk about these odd-even functions. I might take a little bit more room to write than that little corner there, but that's where you're going to put your little table to finish up the work here in this section of homework.